All right, welcome to Algebra 2 Notes 1.2 and 1.3. Again, these are concepts that you should already be familiar with. So we do not teach them in class, but they will be on the first unit exam. So if you looked through your notes and thought, I'm a little hazy on these, then this is the video that you want to watch. All right, we're going to begin with order of operations. And you probably learned it as PEMDAS in middle school. And the thing about PEMDAS is, there's 6 letters, but there's really only 4 operations, right? The first is parentheses, the second is exponents, and then multiplication and division go together, and addition and subtraction go together. So we like to think about it in those 4 steps. So all my grouping symbols, and we work from the inside out, and then we talk about any powers that I'm raising something to, and then multiplication and division, and the order in that goes from left to right, and then addition and subtraction, and that order also goes from left to right. I promise you that there is a question on the test that if you do not use the order of operations correctly, you will bomb. So please be solidly familiar with this order of operation. So we were asked to evaluate the following, and at first glance, A and B look very similar, but they result in very different answers. So let's talk about what these mean in terms of order of operations, right? We've got parentheses going on here, and so P is my first part of PEMDAS, parentheses, and so it means I need to keep this -5 together, and then I need to raise it to the second power. Well, raising anything to a power means just multiplying it by itself that many times. So in this case, it's multiplying -5 times -5. And I know that when I multiply -5 times -5, a negative times a negative is a positive, so I get positive 25. You would think that this would be exactly the same thing, but remember, in PEMDAS, we've got exponents before multiplication. And what we really have going on here is my negative multiplied times 5 squared. So I raise my number to the power first because exponents come before multiplication. So that becomes negative times 25, and then I wind up with negative 25. So you can see that 25 and negative 25 are not at all the answer. If you are doing this in your calculator, and you want to square a -5, then this is what you want to type into your calculator, because your calculator follows the order of operations. And if you type in something like B, it will tell you that -5 squared is -25, and this is the reason why, because it considers it to be a negative times a 5 squared. All right, so this simply requires substitution. We need to substitute in -4 every place there's an M. So I am going to substitute in a -4 for M there, and then a -4 for M there, and then -12. I'm going to raise this to a power. -4 squared becomes positive 16, so I get 3 times 16 plus 5 times -4 minus 12, and then I can go ahead and do my multiplication. This is 48. This becomes -20, because a negative times positive is negative, and that is -12. So let me see, 48 minus 20 is 28, minus 12 is 16. Again, your calculator does the order of operations. So if you were to type in 4 divided by, and then you didn't put these two parentheses, it would only divide the 4 by 2, and then it would start multiplying, and you would get a completely different answer. So it is very important if you're going to type a fraction like this into your calculator that you be sure to include these red parentheses here that I've included. Okay, this next word problem actually has nothing to do with order of operations, but you're going to be seeing a bunch of word problems in this class, so let's go ahead and work it anyway. You are selling fresh squeezed lemonade at a county fair for $3 per glass, which seems a little steep to me, but maybe it's really hot outside and people are willing to pay that. You spend $120 to rent the stand and buy the ingredients and supplies you need. So those are your sunk costs, to put it in economic terms. And you need to write an expression that shows your profit from selling G glasses of lemonade. All right, well, expression means that there is not an equal sign going on. Okay, that's what expression means. So if I'm talking profit, that means the money I make that is more than $120 because I've already lost $120 and I'm selling it for $3 per glass. This word per means that I'm going to multiply these two together. So I'm going to multiply 3 times G, and that gives me how much money I'm going to make, but I have to take away that $120 that I already spent. And then if I sell 50 glasses of lemonade, then I just plug in 50 for G, and I get 150 minus 120, so I make 30 whole fabulous dollars. Not very much money. Hope I didn't work well. Okay, before we were told to evaluate, now we are told to simplify. Simplify simply means combine like terms. And what I mean by like terms are the variables. In order to be a like term, the variable needs to be exactly the same. So not only does the variable need to be the same letter, but the power needs to be the same. So when I combine my like terms, I am going to do whatever the operation is with the coefficients and just keep the variable the same. So 12n minus 7n is 5n. I really hope you remember this stuff because this is very basic and you should remember it. Right here, I've got a bunch of r's, but only 2 of them are r cubes, so those are my 2 like terms. So I'm going to take 8 and subtract 9, and 8 minus 9 is negative 1, so negative 1 or just negative r cubed, and then I'm just going to keep the r squared. These two are not like terms. R cubed is not the same as r squared. And then we always like to write expressions in descending order, which means that the exponent that's highest comes first and then it goes on down from there. So r to the 3rd power comes before r to the 2nd. But I am sure you remember all this. All right, before we can combine our like terms, because these parentheses are not exactly the same, we need to go ahead and distribute. So I'm going to distribute my 9, and I get that, and then I'm going to distribute my negative 6. Really important when my coefficient has a negative in front of it that you distribute that to both terms. So I get negative 6t, and I get negative 42. All right, and then I combine my like terms. So my 2 constants, I'm sorry, not my constants yet, my variables, 9t minus 6t is 3t, and then a negative 36 minus 42 gets me a negative 78. Okay, so now I've combined my constants and I've combined my variables and I am good to go. All right, these two are just more complicated versions of the previous problem in which you distribute and combine like terms. So I'm just going to go ahead and give you the answers and you can work them on your own, and then if you don't come up with that answers, be sure to ask in class. So the answer to this first one is negative 4x minus 38y. And the answer to E over here is 11/6x minus 7/4 y. Let's do a little quick vocabulary. So in this expression, we need to name the coefficients, the constants, the like terms, and the variables. Coefficients are numbers in front of variables. Variables are the ones with the letters. So my coefficients would be, let me see, 3, 4, negative 1, because this negative has an understood 1 here. 7, and then a positive 1, because there's a positive 1 here in front of the y squared. All right, my like terms are the ones that are the same. So let me see, 3x squared plus 7x squared, those would be my 2 like terms, and those are my only like terms. All right, my constant is a number that does not have a variable. So negative 10 is my constant, and then my variables are my x squareds, my x, my xy, and my y squareds. All right, those are my variables. Those are the things that change. So a little vocabulary review. All right, here we ask to simplify the following, and you can do it by just distributing the negatives. So you would get negative a plus b, right? Because a negative times positive is negative, and a negative times a negative is a positive, which would also be the same as b minus a. Okay, and one of the ways that we would say this, so sometimes you might hear this in our class, is the opposite of the quantity a minus b. So all three of these things and this all mean the same thing. All right, so throughout your algebraic career, you have been solving equations by using these properties of equality. The addition property, which says you can add the same number to each side and it will still be equal. The subtraction property, which says you can subtract the same value from each side and it will still be equal. Multiplication and division, same thing, right? You may not have consciously realized that that's what you were doing, but at some point when you first learned algebra, I'm sure you were taught all these. So in Algebra 2, as well as Algebra 1, we frequently ask you to do word problems. And one of the keys to word problems is understanding what kinds of operations we're talking about. And you actually have been talking about names for these operations since grade school, so I'm not going to bore you. But when we talk addition, we usually see something like the word sum, subtraction, difference, multiplication, product, and division, quotient. And there are quotient. There are a bunch more words that indicate these various operations, but this is what we're talking about. An equation will definitely have an equal sign in it, and one of the words that will indicate in a word problem where the equal signs goes is the word is. Pretty much any verb actually indicates that we're talking about that's where the equal sign goes. And then for solution, we're usually talking about what does the variable equal. So what does x equal, or whatever your variable is in your operation. All right, so let's solve some equations. In solving equations, we are going to use inverse operations, right? We're going to undo whatever's being done. So here we've got 2/3 multiplied times d, so I'm going to undo that multiplication with division. Only we don't divide by fractions, we multiply by their reciprocals. So what I'm going to do is I'm going to multiply both sides of my equation by 3/2. So that cancels these out, leaving me with d, and I get 3/2 on that side. All right, same thing over here. I want to solve for my variables, so I'm going to start by getting my variables on the same side, so I'm going to subtract that, and that gets me negative 5y minus 1.6 equals 0.9, so then I'm going to add, because I undo subtraction with addition, so I'm going to add 1.6 to both sides, and this gets me negative 5y equals, and then this is 2.5, and then I'm going to undo multiplication with division. So this gets me y equals, and I get negative 0.5. Okay, so we're going to solve this problem here, and something interesting is going to happen this time. So we've got this 3x minus 7 on this side. I'm going to go ahead and distribute, and that gets me 3x plus 33 minus 24 on that side. All right, so I need to keep combining my like terms. So I get 3x minus 7 equals 3x, and these two added together get me 9. Okay, so I can either recognize right now that something's going to go a little wrong, or I can keep solving. So let's get all my x's on both sides. So I subtract 3x from both sides, and when I do that, I find out that these cancel and these cancel, and I get negative 7 equals 9. Well, obviously, negative 7 does not equal 9, so that means that this one has no solution. There is no value that I can put in for x that will give me a solution to this equation. All right. I think you're getting the hang of me solving problems, so I'm not going to solve any more problems here. I'm just going to go ahead and give you the answer. If you want to solve the problem, you can check and see whether or not you get the right answer. So the answer to D here is that A equals negative 15 halves. And here's an example of an English sentence that we need to translate into math. So twice a number increased by 4 is 18. So we're just going to verbatim translate it. So twice a number means 2 times a number. We're just going to use n for a number. And then increased by, well, increased by means plus 4, and then is 18. And then you can go on to solve that for whatever n equals, but it's pretty straightforward. So we're going to keep going. A number, this time let's use x for our number, decreased by 6, so minus 6, is, there's my equal sign, negative 3. And again, easy to solve. All right, we're still just solving equations here, but I do want to solve this one because something interesting happens to this one too. Okay, so I'm going to start by combining my like terms. So I get 2x minus 8 equals 5x minus 3x equals negative 2x. I'm sorry, positive 2x. Math. And all right, so I get the same thing on both sides of my equation. So I can either recognize right now, something interesting is going on, or I can keep going. I can keep going by subtracting 2x from both sides, and those cancel, and that leaves me with 8 equals 8, which is a true statement. Or I can keep going and subtract 8 from both sides, which leaves me that 0 equals 0, which is another true statement. And what this means is it doesn't matter what I plug in for x, because any number will work. So unlike our previous one in which no number would work and we got no solution, in this one any number will work, and we call that infinitely many solutions. Infinite, because I can spell. Infinitely many solutions. And we sometimes abbreviate that as IMS, or we can say all real numbers, and we use this symbol for all real numbers, right? So either one of these or this is a possibility. Make sure you know the difference between you getting a statement, which is, let me see back here, that is false, always false, in which case it is no solution, or you get a statement that is always true, and this was an always true statement, this was an always true statement. So at any point when you realize that that statement is always true, then you know that it's infinitely many solutions. Make sure you understand the difference between those two. And this one's a pretty straightforward one to solve, so I'm not going to solve it for you. I'm just going to give you the answer, which is x equals 18. I feel like I'm beating a dead horse, so I'm not going to even solve any more of these. Let's talk about this one briefly. Twice the square of a number is 32. Okay, so twice means 2 times. Square of a number means the same thing as a number squared, all right? If it was square root, it would have said square root, but it's talking about square of a number. So twice x squared is 32. Okay, and then you can go ahead and solve. Let's write these out. 8 less than 3 times the number is 19. Okay, you have to be careful because this right here, less than, that than is my flip word. What it means is I do not write it in the order in which it's written. I flip these two around. So 3 times a number, that would be 3n. And then 8 less than is an 8 and a minus, but it goes like this. So it goes 3n minus 8 because I flip these two around, and then is 19. Okay. That is different than 8 is less than 3 times a number. Okay. Once the is joins the less than, then we're talking about this symbol. Okay, so less than without the is means that the equal sign goes elsewhere, and this tells me that I'm doing subtraction. Is less than means I'm talking about this symbol. So 8 is less than 3 times a number, and those are the difference between them. Okay, let's talk real fast about properties of negatives, which again, this should be just a quick review. This means I take -1 and multiply it by whatever a is. Okay. This one here, a negative times a negative becomes a positive. Right? So negative times a negative is a positive a. This, do not distribute this negative to both the a and the b. This is like -1 times a times b. Okay, the negative doesn't get distributed to both because that would be using it twice. But in this case, the negative does get distributed to both because it's outside parentheses. All right, so in this case, if the negative is outside parentheses, I would distribute it to both the a and the b. Okay, and in this case, I've got addition going on, and the negative is outside of parentheses, so I do go ahead and do that. I distribute it. All right. Okay, and then there's just a couple hints for word problems. You want to translate the words, the English to math. You want to look for any patterns that exist. You can make a picture, you can draw a diagram, you can make a table. Okay, just use all your skills that you've been taught in the past to solve word problems in Algebra 2. One thing that you do always want to do, though, is if you're going to use variables, then you must name your variable. We are very picky about this. So, for example, if I have a word problem and I want to use x, then I need to say let x equal the number of widgets. Okay? You always need to begin with this statement before you can start writing problems that contain x, okay? Or we're not going to know what x stands for. So make sure that this statement is always included in any word problems that you go to solve. All right, that concludes these notes. Again, if you have any questions over anything that we have covered or over anything you missed on your pretest, please be sure to ask your math teacher. Thanks.